So in Unit 3, we're going to focus on two really key computer science concepts. One of them is called Boolean statements, and the second one is called conditionals. And what those are going to allow us to do when we tie them together is they're going to allow us to make decisions within our program. And you'll start to see that making decisions is the key component of many of the computer science programs that you interact with and that you're going to write in my class. So in this unit, there are 6 different lessons, and what we're going to start with today is just the basics of decision making. So how do we make decisions, how do we read that code, and etc. So your 2 learning targets for today are that you can define and provide examples of what are called algorithms, and hopefully that word's not new to you. Hopefully it's something you've been exposed to before in a math class. And the second learning target is that you can define, identify, evaluate, and write what are called Boolean statements. And hopefully most of you are already thinking, Boolean, I've heard that before. We have. This relates to George Boole, who we talked about before, who dealt with true and false values being ones and zeros. So that's a concept we're going to be talking about today. So to begin, we need to define the word algorithm because algorithms are really the main focus of computer science. It's why computer science exists in the first place. So an algorithm is a series of steps or actions that are performed in a very specific order. So the 2 things you need to know are they are steps in an order. And you can see that down here, the 2 key aspects. The actions need to be executed, and there is an order in which they need to be done. So that's the big key parts of an algorithm. So algorithms can really be found in our everyday life. Here are just 3 examples of where you might see them. The most common one, kind of talked about in computer science, is making a peanut butter and jelly sandwich, and the steps that you take to make it, you have to do it in a specific order, and you have to follow very, very key steps. Same thing with finding the area of a trapezoid. Again, we already wrote this program. You wrote it last unit. You had to get the different lengths of height, base 1 and base 2, add the bases together, multiply that by the height, multiply that by 1/2, and then you had to just add the units onto it and output what that was. And then the third one, I call this a rise and shine algorithm. Get out of bed, take off your pajamas, take a shower. Again, things that have to be done, and they have to be done in a specific order. If you take your shower before you take off your pajamas, you're going to be in trouble. So these are just 3 examples. There are plenty more. Every time you write a computer program, you are writing what's called an algorithm. So just kind of keep that in mind as we move forward in this class. So the second key vocabulary term for this lesson is the term pseudocode. And pseudocode is just a combination of English and computer programming language put together. It's a really good thing to use when you're trying to design a program. A lot of programmers will kind of sketch their ideas onto a notebook sheet of paper and they'll put out, well, this needs to happen, this needs to happen, this needs to happen. And that's when they're sketching out their order and they're getting an idea of how they're going to create their program, the big picture, how they're going to program each little piece. Basically, all pseudocode does is it's a quicker way than writing exact computer programming language code. It's a quicker way to just show the steps that are involved in actually solving that computer science problem. And what this does is it combines your algorithm that you're trying to solve, that step-by-step process, with some partial computer code. And as you start to program more and more and more, pseudocode is something that if you write out an outline or a rough draft on a separate sheet of paper, that pre-planning is really going to help you to be a more successful coder. The bigger and bigger programs that you write, the harder and harder it is to just dive in and spit out that code. So when you're writing in pseudocode, you're really creating a plan of how you're going to attack and solve a specific algorithm. The third keyword for today's lesson is a flowchart. And a flowchart, all it is a graphical representation of an algorithm or even just a portion of an algorithm. Sometimes the algorithm is such a big problem to solve that you break it into small ones and you flowchart that instead. All of the actions for flowcharts are connected with arrows to show a flow of action through the program. So basically what this is a visual representation of your pseudocode put into a picture rather than just words. Then there are 3 specific types of control structures that are used to represent this flow. Sequential, which I'll discuss a little further in just a second. We've actually been writing sequential programs, and you could have written sequential flowcharts for them. There's what are called selection, which are what we're going to study this particular chapter. And then there are what we call repetition, which we'll actually study when we get to Unit 4, and that's where we repeat code in a very specific way. So we have these three different control structures, and they are really the main focus of computer science. So as I mentioned on the previous slide, we've actually been studying what are called sequential or linear programs. It's every program we've written so far. It has one flow of action. It does this line, then this line, then this line, then this line. Essentially, every single line of our code has run, and it's used for very, very basic programs. So you can see here we have a nice picture of how this works. What your computer does when it runs your current programs is it runs this statement, moves on, runs the next statement, moves on, runs the next statement, moves on, and keeps going until it's run every single line of code in your program. This was used for our distance formula program, this was used for drawing the flags, and today we're actually going to start looking at what other options we have besides these sequential programs, because as I said before, these are really for the most basic of programs. They have to run every line, and we want to design some programs that maybe run differently depending on the type of input the user puts into their program. So on the previous slide, I showed you how every program we've written so far has always done the exact same thing every time it runs. What we're going to focus on this chapter is what happens if we want our computers to respond differently depending on the user's input, which is where these decisions we've talked about come into play. And so a little bit later on in this lesson, you're going to create the grades program. And what the grades program is going to do is it's going to ask a student to enter their grade. And then if the student enters in a passing grade, it will say, "Congratulations, you've passed the course." And if the student enters in a failing grade, the program will tell them, well, unfortunately, you did not pass the course. And the key words that you're going to see every time that decisions are involved in a program are these words if. These words if are really saying, well, I want this to happen if this specific condition is met, and I want something else to happen if this specific condition is met. So there are different things happening, which means we have to make a decision within our program about how we want it to respond. And when we have to make decisions, this is where Boolean expressions come into play. And a Boolean expression is an expression that evaluates to be true or false. So this is like the ones and the zeros that George Boole invented back in our computer history unit that we talked about. So Boolean expressions evaluate to be true and false, and they are how we make a decision. If a statement is true, we do one thing. If a statement is false, we do another. And so there are a bunch of comparison operators or relational operators that we can use to help us make these comparisons. And so relational, what that means, why they're called relational operators, are because those statements define a relationship between two items. Something is greater than, less than, equal to, etc. But again, Boolean expressions, those are how we are actually going to make our decisions. So on this slide, you'll see the 7 main Python relational operators. And what you'll notice here on the left is that we actually have their mathematical equivalent on the left, and then I showed you how it looks in Python. So something I want you to notice is that if you're trying to compare two things that are equal, in Python you actually have to put a double equal sign. Remember, our single equal sign was for assignment. A double equal sign actually says, okay, are these two things equal? Then the second one here, the not equal to, there isn't like an equal sign with a slash that we can actually type in. So that exclamation point there actually means not. And that's how we can actually assess whether or not two things are not equal, because maybe sometimes you only want something to happen if the two items are not the same. Then greater than and less than both work just as you would expect them to. And then the less than or equal to or greater than or equal to, how those are a little bit different is there isn't a line underneath that you can actually type in on your computer, but we do those by saying less than and then the equal sign, greater than and then the equal sign. So note that all of these statements, when we use them in Python over here, every single one of these statements can evaluate to be true or false. None of them are going to assign a value or anything like that. Every statement, if we know the values for the variables contained within them, will evaluate to be a true or false value and therefore can be used to help us make a decision. So on this slide, you'll see that I have a couple examples of code that looks like things we'll actually be typing out this chapter. And what I want you to notice is that there are Boolean statements every time we make a decision. So here we have a Boolean statement using the double equals. Here using the not equals, the greater than, the less than, greater than or equal to, less than or equal to. Same thing up here. These are called complex Boolean statements, but again, all of them are used to make decisions. And what happens is if the statement is true, one thing happens in the code, and if the statement is false, another thing happens. And that's what we'll actually be dissecting and looking at over the next few lessons. So on this page, as well as in your notes packet, you will see that there are 8 Boolean statements here for you to evaluate. And what you need to do is take these 3 values up here and evaluate and decide whether or not the statement is true or false. So for example, I'll walk through number 1 with you. This one says 5 minus 10 is greater than 0. So if we actually evaluate the left-hand side of that, we end up with that becoming negative 5 is greater than 0. And when we look at that statement, we know that that statement is not a true statement and it is instead false. So this Boolean statement would evaluate to be false. What I'd like you to do is pause the video, solve through those 8, see if you can get the right conclusion for them, and then if you restart the video, it'll take you to the answers on the next slide so that you can check how you did. So hopefully you attempted those 8 problems and you can now check your answers. A couple of things to point out to you that some kids get tripped up on. On number 3 here, when it says 2 does not equal negative 2, that kind of seems like a weird statement, but that not equal to symbol is saying these 2 numbers are not equal, which is in fact true. A second problem that kids typically get a little tripped up on is up here where it says negative 10 is greater than or equal to negative 20. That is true. Negative 20 is smaller. In number 6, noting here, negative 2 is less than negative 2, that is a false statement. If there was an equal to along with that less than symbol, it would be true, but here that is false. Here in number 7, negative 20 is not equal to negative 20, that is a false statement. And then down here in number 8, this is a trick question. This actually evaluates to be 6 and is not even a Boolean statement. So if this was written in place of where a Boolean statement should be, you would say that this was invalid inside of that decision-making piece of code. You would tell me that it was wrong, and then you would move on, and it would need to be fixed before that code could actually run.